this is starting off with kind of rehashing what we talked about yesterday. Hopefully that assignment wasn't very taxing, but I want to talk about those angles being.
I wasn't here yesterday.
I'll open it back up.
Oh, okay.
Those are alternate interior angles, correct? Alternate interior angles. There's only one pair of them, okay? Remember what the word, all these that have two describers or two adjectives for them, okay? The first one tells you, the first word tells you on what side of the transversal to pay attention to. So alternate means that there's going to be one on one side and one on the other side. The word interior means that second word references the two red lines. So we're going to look on the inside of the two red lines. Okay? Remember the blue line was called a transversal, right? Okay? So alternate interior angles would be that grouping of angles right there. Now, that is just one set. There's the other set. Okay? Is that okay with everybody? We visualized that from yesterday? Yes.
I understand this, but when there's more than just three lines,
Okay, I'll show you how to kind of adjust for that here in a moment.
So was the homework like the 2-6 homework? Or
It was 3-1.
Huh?
3-1. 2-6 is still open though. One work on. Here is a pair of alternate exterior angles. Okay, alternate exterior angles. Hopefully, once you see that pair, you can visualize the second pair, right? Again, those are on alternate sides of the transversal. The blue line's transversal. They're on different sides. And they are on the exterior of your red lines, right? Okay. So those are alternate exterior. Here are corresponding. That's one pair of corresponding angles. Now, yesterday at the end of the day, or in the period, I kind of tried to explain to you, if you were to take this line here and slide it up so it became the other line, you see how the green angle would become or morph into that red one? Okay. So if that happens, if you're able to visualize that for those two angles, those are corresponding. If it happens then for those two, is that same relationship going to happen, the same kind of morphing of one, the purple one into the orange one? So those are corresponding. What we mean is they're essentially in the same position. If I were to just see if I can do this real quick. I just look at that, okay, and kind of think about the position of that angle right there. Is that the same as the position of that angle? That kind of makes sense in regards to the transversal and just one of those red lines. So that idea, because those positions are the same, we're looking at the idea of being corresponding. There should be 4 groups of corresponding. There's the third group, and then here's the fourth group. Okay. The last group, which is ultimately going to be one of the key components of the things that we learned today, are those two angles. Okay, and those are same side interior angles. Same side meaning they're on the same side of the transversal. Interior meaning they're on the inside of the red line. Okay, and then the other set would be right there. Okay. Now, something to talk about, something to think about is if I highlight both those, look at just one set. Okay, if I put that spotlight back up here. Are those two angles right there still a linear pair? They're still supplementary, right? So we're just building on top of things that we already know. So inside this picture, we're going to develop 4 more facts today, 4 more ideas, 4 more concepts. They're absolutely true all the time. But what we already know to exist, like linear pairs, or if I look at, say, look at these two right here. Are they vertical? So all the relationships that we know about vertical angles are still going to exist. Okay, we're just adding new things, and when we add new ideas and new concepts, new truths, they never contradict the old facts. Okay, contradict meaning that they never kind of go against what they already say, right? Never make what we already know to be true false. Okay, so those are the angles that we're going to be interested in. Okay, now The question earlier was when we've got maybe something, are you talking about something like this, Sam, with that picture? And trying to decide what angles are, I think they would ask you like which ones are alternate interior, which ones are corresponding, that kind of thing. So if I go like just number these 1, 2, 3, 4, 5, 6, 7, 8. Shut up. All right, so you feel like that, right? Okay. So the question would be like if I give you angle 1, identify maybe some angles that are alternate exterior with angle 1. Okay. This is how you would do that. You would first say, okay, I'm going to find the ones that are alternate exterior with the current black line. So I kind of visually hide the other one. Does that make sense? Okay. And when I hide that other one, these 4 angles kind of disappear, right? So would you say angle 1 is alternate exterior with 8? Okay. So that is the first step of this. And then the next thing would be, okay, we'll bring that back in, and now I'm going to hide that one. And now would you also say angle 1 is alternate exterior with 12? Okay. So that's kind of the best way I think to do it. Now, obviously, you probably don't have the programming when you're doing your homework to click on something and hide it and show it and that kind of thing. The idea is that we might have to redraw it. We might have to take, a piece of paper and cover up one of the lines that we're not dealing with or something like that. I like to use colored pencils or highlighters again and just highlight the 2 that I'm interested in. Maybe I highlight 2 of them red and then my transversal blue like I have up here. And it might shed light on things a little better. Other examples of that's a really good question, is because you're going to see stuff eventually like this. Okay? And that brings in a lot more angles, right? What happens is that, would you guys agree if I hide this one, that we have now this red one as a transversal for the black and the blue one? If I hide that red one, this red one is the transversal for the black and blue. When we hide the black one, I have to get this back to the picture we started with. So that's a transversal then, the blue one is. And then if I hide the blue one, is the black one now a transversal? All right? So there we actually have 4 different transversals we could look at and analyze. And the best thing to do, just to eliminate clutter, is to just focus on one of them, okay? Just focus on the picture that provides you just one transversal. And that's kind of my argument to you guys all year long, is when your picture starts to get messy, you might have to redraw it, and redraw it, leaving out things that maybe aren't pertaining to the problem, okay? There will be a lot of situations throughout the class where they add stuff just to confuse you. They add stuff just to make it look messy. For instance, later on, and even in this section or this chapter, they'll do something like this. They'll add that black segment and start asking you about the blue transversal, okay? Well, that black segment is just there to visually congest the picture, just to mess you up. If we can realize that and realize that all the things that the problem's talking about never deals with anything with that black segment is unimportant to us, and we get rid of it. And what are we left with then when we get rid of it? We're left with the simplest version of 2 lines being cut with a transversal. Every single time we see this, every time we talk about 2 lines cut by transversal, this is kind of the simplest version of 2 lines being cut by transversal. It could get messier, obviously, with putting more things in. You can rotate. Okay, a lot of times people like to look at them. All the theorems we talked about today are going to be kind of like that, is what we start with. But you can rotate it. You can change the distance between the 2 red lines. You can change the slope of all 3 lines. But essentially what we're trying to do is narrow down our problem to that. All right, and then hopefully make these arguments. One of the arguments I want to make, and hopefully maybe you've already thought about this or come to this conclusion, what do you guys think about these two red lines? What do you think the argument is in the relationship to one another? They're parallel, okay? And just to prove that to you, we talked about yesterday, if we find the slope of those red lines, the slopes are the same, right? And that then guarantees that they are indeed parallel. And when I change one of them, it automatically changes the other. That's the way I kind of constructed this using GeoGebra. Okay, you guys remember doing constructions a couple weeks ago? All right, so everything I've done in here is based off of constructions that we did a couple weeks ago. All right, so when I show you those two angles right there, that pair of alternate interior angles, okay? If I hit play, it's going to go through an animation here to hopefully get you to kind of visualize a property that we're going to deal with today. What do you think you're going to be able to say if we start off with parallel lines? What are we going to say about those two angles? Okay? They're the same. Okay? As I move that angle, okay, it never changes size, right? Okay, I do what we call a translation, which is you guys remember taking, like in 7th and 8th grade, taking shapes and moving them left, right, up, and down? That's what I just did with that angle. The shape, I moved it left, right, up, and down. It's a combination of things. We also did a rotation. You guys remember doing rotations? All right, we'll do those things again later this year. Those are called transformations, and they are what we call rigid motion, meaning that when we do those, the size of the object that we start with does not change. Okay, so that maroon or red angle there slides or translates and then rotates, and it does not change its size. So we find out that if we start with parallel lines, then alternate interior angles are congruent. Does that make sense, everybody? Okay. Now here's a question that I want to ask. Let's do this. See if I can stop. Oh, stop. Just got the animation go too fast. Let me see if I can go down. All right, so, I guess it won't fall. Yes, it will. All right. So if I stop it right there, look at the two maroon or two red angles now. What kind of angles are they based on their location point on it? Okay. Sam? Corresponding, right? So what do you think we're going to say about corresponding angles? They're congruent. Okay? And what leads us then to alternate interior angles eventually being congruent is because if those corresponding ones are congruent, that corresponding one up top is vertical to an alternate interior one, right? So we can make that link because they're vertical, they got to be the same. So then all three of those angles, because of the relationship that we understand about in the past, have to be congruent. So you're going to see that corresponding angles are congruent. You see alternate exterior angles are congruent. If I just show you a group of alternate exterior angles, I'm going to reset this, make that clear. If I look at those two alternate exterior angles, what do you think the argument's going to be about them? They're congruent, okay? Now I'm going to throw a wrench into things. Maybe the picture here isn't severe enough, but let's make it look like that. Do those two angles look congruent? No, okay? But think about this. Is that angle right there, let's see here if I can get the right one, corresponding to that orange one? Does that make sense to everybody? Now what about that orange one and that big purple one up top? They're supplementary. Okay? So if that orange one is the same thing as this bottom purple one, and these two were supplementary, doesn't it make sense that those two have to be supplementary as well? Okay? So same side interior angles are going to be supplementary. Okay? We're going to write these statements down, okay? And I don't know that we didn't get through all of them in either class today. But these are what we call properties of parallel lines, okay? When we go through a proof, guys, we have seen when we say the word vertical does not provide us anything based off its definition. Whenever I see vertical, two things are vertical angles, I want to say they're congruent right away, though, right? But that comes from my postulate, or from a theorem about vertical angles, okay? When we see a linear pair, that definition doesn't get me anything in regards to congruencies or anything like that. But the linear pair postulate tells me that angles are supplementary, correct? The next vocabulary word that really doesn't teach us anything inside our proof is the word parallel. Because parallel just says it's two coplanar lines that do not intersect. It doesn't give me any equations. It doesn't give me any relationships. The vocabulary words definition are kind of useless, okay, in our proof. However, they should maybe open our eyes to a handful of theorems and postulates that we're going to kind of uncover today, that you kind of just discussed with me in that applet, okay? Before we do anything, guys, think about this. If I'm in a class and somebody's writing a PowerPoint and they italicize something, they bolded it, they underline it, they make it a different color, it's probably something that's pretty darn important, right? Please write down that thing up there in the green, okay? You only know these things to be true if we start with parallel lines, okay? Alex, you have a question?
Oh, I was going to wonder if like the stuff we did this before, 3 pages, what we did.
Yeah, part of what we just talked about was just identifying the angles where they're at in locations that all together. So one of the things that gets asked all the time, and you'll see it, you might see it on the course again, you'll definitely see it on my test or quizzes. I ask the question, I just phrase it this way: same side interior angles are always, sometimes never supplementary. Same side interior angles are always, sometimes never supplementary. And you cannot answer that real well because you don't know anything about the lines that created the same side interior angle, correct? When I say the phrase same side interior angles are supplementary. You know nothing about, in this case, maybe lines L and M. Look at the picture up there, okay? Once I say they're parallel, now you can make a conclusion, right? So if my phrase that I ask you is same side interior angles are always, sometimes, never supplementary, the answer to that is sometimes. Because when the lines are parallel, yes, they're supplementary. When the lines are not parallel, do we really know? The answer is no. Okay? Sometimes they might be, but sometimes they might not be. Okay? And actually, when they're not parallel, they're not going to be supplementary. Okay? So that's a key phrase. And I ask that a lot, just not just about same side interior. I'll ask the same question about corresponding, some question about alternate interior, alternate exterior, and it relates back to how we read our theorems and our postulates. They're if-then statements, right? So I can only come to the conclusion of supplementary here when I know that the if statement is occurring, or the if statement is in front of me and it's true. This has to be valid first. It has to be occurring first before I can make any argument about the same side interior angles being supplementary. Okay? So if you don't know that that's happening, it might be, it might not be. But you don't know it, you shouldn't make a conclusion about it. Does that make sense? Okay? You know, when you first meet somebody, you don't know a lot about them. You probably shouldn't just make ridiculous conclusions about them without getting to know them a little bit. And that's the idea that's going on here. I don't know anything about what's occurring in front of me in regards to the picture, in regards to the information. I don't want to make just haphazard conclusions. Okay? So here we're saying 3 and 6 because they're same side interior angles. 3 and 6 should add up to 180. See that there? And 4 and 5 as well should have 180. Now that being said, are 4 and 3 still going to add up to 180 as well? And same thing with 5 and 6, right? Those are our old linear pairs, and they should absolutely still be linear pairs. Okay? So as we learn new things, as we learn new facts, new truths, okay, they never contradict the old facts. Okay? Think about this algebraically. You've been told since about 6th grade you can't divide by 0, right? You will never, throughout all of mathematics, ever come to a situation say, hey, now that rule doesn't work. Now it's valid to divide by 0. If it's not allowable at one stance or one situation, then it's never allowed. Okay. Here, if we have 5 and 6 being a linear pair somewhere else, then they have to be a linear pair here as well. They cannot be contradicted by a new statement. Does that make sense, everybody? Okay. All right, that's a postulate. Some textbooks actually call that a theorem, and one of our other statements is a postulate. Okay, it doesn't really matter to me too much, but I'm going to kind of use the structure that your textbook uses, so they call us a postulate. They also give it a name. They call it the same side interior angles postulate. That's great. That's fun. It's awesome. You want to use it, use it. Some textbooks don't give it a name. Okay, some textbooks just leave it as if a transversal intersects two parallel lines, then same side interior angles are supplementary. Okay, I learned this about 19 years ago in this classroom, and the textbook used the word cuts instead of intersects. And for the life of me, no matter how many years in a row that I've used the word intersect, I can't get cuts out of my head. Okay, so you're going to hear me say the word cuts every once in a while. It's the same thing as intersect. All right, so make sure we're all on the same page with that. You did? No, I went to a different school, but I attended this building. Unbelievable. Mr. Leidy. No, he does not teach here anymore. All right, so this question tells me measure of angle 3 is 55 degrees. All right, if measure of angle 3 is 55 degrees, we should be able to work through this problem, provided that we know something about these lines. This little notation right here, what do you guys think that notation in those lines means? It means the lines are parallel. Okay. If I do not have that notation, we'll talk about this in one of the classes today. If I do not have that notation, so maybe it looks like this. Can I say that they're not parallel? No. Okay? Remember, if you don't know, you don't know. So you don't make a conclusion, right? So just because it says that they're, I can't make the argument that they are not, or that they are parallel. So because there's no markings in there, I can't say that they are parallel. So if you can't say something is parallel, it does not automatically mean that it's got to be the opposite and it's not parallel. Does that make sense? It's just no conclusion. But the instant I put those arrows in there, okay, now we know they're parallel. Okay? And now if we know they're parallel, and I tell you that this is 55 degrees, do you automatically know what angle 8 is? Well, the postulate just said it. We just talked about same side interior angles have to be what? Supplementary. Okay? So if one of them is 55, the other one's got to be 180 minus 55, right? Now that we know that, there are 6 angles up there that are missing, but you should be able to find every one of them. Okay? What's angle 1 got to be? 55. Why? Vertical with a 3, right? What's angle 4 got to be? 1.5. Why? Okay, I heard that it's a linear pair that's supplementary with angle 1, right? I heard maybe it's a linear pair with 3. Ian said it's corresponding to 8, right? Absolutely. Okay, we haven't talked about the corresponding relationship yet, other than through the picture and the applicant before we haven't written down. But corresponding angles will be congruent. Okay? What's angle 6 going to be? 125. Why? It's vertical with 8. What's another reason? It's alternate exterior with 4, right? We haven't written that theorem down, but that's going to be a fact, that alternate exterior angles are congruent. So what I'm trying to get at here, guys, is when I ask you a reason of why one of these angles is what it is, you have a lot of different answers that could be true. All right? Something that we're interested in is being able to decipher all of those and understand all of those. But the concept is that if these two are equal because they're vertical, and these two are what they are because they're supplementary, this should not be 55 because they're vertical and then something different because they're supplementary. Does that make sense? They both have to be, angle 1 has to be 55 in both relationships, because of both relationships. Hopefully we see that angle 2 is 125, angle 5 is 55, and 7 is 55, right? And you see here all those relations that we talked about at the beginning, alternate interior congruent, There's 2 and 8, 3 and 5. They're congruent. Alternate exterior, all your corresponding angles. Is that okay with everybody? Can we do something like that? Okay. Again, you're going to see in your homework they might try to confuse you with like putting another line in there, something like that. If you don't need that line, don't use that line. Redraw the picture without it. Okay. So this is just the theorem that states that alternate interior angles are congruent. And we're going to have a theorem, guys, that says alternate interior angles are congruent, alternate exterior angles are congruent, and corresponding angles are congruent. Okay? And I don't know, we might not discuss those until tomorrow, those additional ones. But the idea is, the way that I remember it, is that everything is congruent. Every grouping is congruent until I get the same side, right? And I remember the same side supplementary. What in English do you have? What kind of phrase is that? It's all the non-synonym. That's a spice, isn't it? It's an alliteration, right? Same side supplementary. Using the same consonant to start off all those words. You guys have heard that before, right? Alliteration. So that's how I remember the same side supplementary, the different one. Okay? Same side supplementary. But everything else, alternate exterior, alternate interior, corresponding, they develop congruencies. Okay? This one says if a transversal intersects or cuts 2 parallel lines, then alternate interior angles are congruent. So 4 should be congruent to 6, and 5 should be congruent to 3. They're going to ask us, can you prove in like a textbook or a math question, they might say, prove the alternate interior angles theorem. Okay? Or at the end of the course exam, some of the previous proofs that I've seen on that will actually say, prove this particular geometry theorem that you talked about in your classes. So that might say, prove the alternate interior angles theorem, but they won't give you the given, and they won't give you the proof. They just start you off with that phrase, prove the alternate interior angle theorem. So there's a couple things. We need to know what it says, and we need to know how to kind of decipher that into a given in our proof. So knowing what it says there on the left, okay, if a transversal intersects 2 parallel lines. So remember, that if part is your given, right? That's your given. So you need 2 parallel lines. You need 2 specific parallel lines to talk about. Name them whatever you want. I'm going to name them L and M. That's our given. L is parallel to M. You guys agree that that's 2 parallel lines? Okay. Now, I can even write here intersect by a transversal T. Maybe name that T or something like that. But usually we don't write that the parts that they're intersected by transversal. Usually the accompanying picture kind of proves that or shows that. Does that make sense? But you can add it if you want to the given. The then says, then alternate interior angles are congruent. Well, we need specific alternate interior angles to talk about. So we write some numbers down here, whether you use 4, 3, 5, and 6, or use any other numbers or letters that you want to, that's fine. But 4 and 6 would be a grouping of alternate interior, right? Or 3 and 5 would be a grouping of alternate interior. We're going to pick off one of those groups and see if we can prove maybe 4 and 6 congruent. If I can prove 4 and 6 congruent, I have proven alternate interior angles are congruent, right? Well, 1 and 3 and 5, they're alternate interior. So just proving one set of these is enough to prove that both sets are congruent. Does that make sense? Okay. So we set things up, we set our proof up using that idea. This is what we're looking for as our given in our proof. The one thing, I think I said at the beginning, the word parallel, you're seeing it as a symbol here. The word parallel does not get me any new statements in the left-hand column. It doesn't really provide me any new ideas, okay? But it should trigger a postulate. What was the first postulate we talked about? Same side interior angle, okay? So when I see parallel right now, because we haven't talked about, we haven't shown you the theorems or walked through the theorem, this is what we're going to do in the next couple of days, is independently prove the alternate interior angle theorem, the alternate exterior angle theorem, the corresponding angle theorem. Okay, that's kind of my goal for the next couple of days. But right now, this is the first one we've come across. So the only thing I can use to prove it is what has come before it, and the only thing that's come before it is same side interior, right? Okay? So that's the postulate that we're going to use. So that's what that parallel word triggers, okay? On Thursday, when we come to class, we've already talked about all four of these relationships. If you see the word parallel, you can use in any four that you want, or any one of the four that you want. Does that make sense? Okay? But we haven't learned those other ones yet. We haven't written them down, so we're not going to use them. So, Trey told us that we're going to use that same side, interior angles are supplementary. So let's write down what that would mean for us. Which pair of angles up there would be same side interior? 3 and 6. If they're going to be supplementary, then we know that we can write that measure of angle 3 plus the measure of angle 6 equals 180, right? Same side, supplementary angles, the postulate. Okay. Now I'm going to write it that way. We're going to use that because that's what Math Excel, I think, for the most part, is going to use. Like I said earlier, though, some textbooks might not call it that. I think the safest thing, especially if they only have fourth exam, is to actually write, if two parallel lines cut by transversal or are cut by transversal, then same side, and I'll write this out, the same side interior angles are supplementary, right? That's what I would probably type out or be looking for on the of course exam if they've got me kind of maybe picking from a window, or you're going to see sometimes on the of course exam they have things like this where you're moving these things around in the spots. You've seen that kind of stuff on testing quizzes before, right? Yeah, I got predefined things, you're just kind of reordering them. You'd be looking for that phrase, okay? Same side interior angles, same side supplementary angles postulate says if two parallel lines are cut by transversal, same side interior angles supplementary. And that's the thing. Sometimes later on, guys, there's going to be theorems where they don't have names, and you have to write out what the theorem says. Okay, it's just the nature of some of them that we deal with. Okay, so now. We talked last week that when we're doing a proof, guys, we want to kind of use past experiences. Every time that you go through life, and this, I talked about this with the last class because they're asking, when am I going to do this? When am I going to prove something like this in my real life? Probably never. You're probably never out of high school going to go through and say, here are two parallel lines, and let's go through the proof. That's not going to happen, okay? But the logic and the line of thought that you use to prove things, the line of thought that you use to make an argument, you're going to use all the time. So we're trying to teach you mathematical concepts and practice procedures and lines of thought and how you progress through arguments using math content. Does that make sense? Okay. A lot of people that are lawyers, a lot of people that are like pastors and preachers and stuff like that have undergrad work in mathematics. Mathematics is an understanding of a bunch of laws and rules, right? And isn't that essentially what being a lawyer is? Understanding a lot of rules and laws, okay, and being able to interpret them, piece them together. And isn't that what religion is as well? Okay? So that kind of idea or example, I think, maybe shows you how we can use a mathematical framework to kind of work through problems, okay? Whenever you come across a problem in real life, don't you kind of think about, okay, have I seen something like this before? Have I experienced something either exactly like this or similar to this before? And then think about, okay, now how did I address it before? And what was the outcome? Was it good or bad? If it was a good outcome, then let's use the same approach, okay? If it's a bad outcome, let's adjust it and see if we get something better, right? That's how you approach the problem. Hopefully when we see this, you say, okay, there's some things that are in this problem that look similar to how I've approached something else in the past. In the past, we have seen angle 3 plus angle 6 equals 180, right? Might not have been exact. It might have been angle 1 and angle 2. Okay, it might have been angle R and angle W. Don't care. Okay? We had two angles after 180. And we had two ways of approaching that. One way was to substitute. Okay, so one way of getting through this problem would be to substitute. Now, knowing with proofs, we can only substitute if I have previously stated that things were Well, I'm at line 2 right now. I haven't previously stated much of anything, right? Look at line 1. That's the only thing that I've stated. So can I pull out 3 and replace it with something? Can I pull out 6 and replace it with something? No. So substitution fails me here. So the only other way that we've approached this similar type of problem is that we have created a second sum that was equal to 180. That's the only other way that we can do this. Okay? So look at your picture up there. What's the second sum that you know is going to equal 180? Okay? 3 and 4. Measure of angle 3 plus measure of angle 4 equals 180. And how do you know that? Because you have a fantastic math teacher. Great's not good enough. How do you know? Linear pair posture. Okay? Those two angles are a linear pair. They form line L. Okay? And if that's the case, the linear pair posture says that all linear pairs are supplementary. Okay? So linear pair posture. All right, previous situation led us to this idea, didn't they? If those two things are 180, 180 is equal to 180. What can you say about that thing compared to that thing? They're the same, right? 3 plus 6 should equal 3 plus 4. What's that reason? This is the same. This statement right here is the same as number 2, right? Except for the 180 got replaced with what it was equal to. Substitution. What's on both sides there? 3. In the past, we've gotten rid of that 3, right? Well, why not do the same thing? It worked earlier. Let's see if it works here. What do you get when you remove them? 6 plus 4, or 6 equals 4, sorry. So 6 equals 4, what's that reason? I crossed out the wrong one. There we go. What allows me to get rid of 3 that was on both sides? Subtraction. Subtract proper equal. Okay. Now, number 6. Now we've got two numbers that are equal, but those two numbers come from angles, right? So we have, because they both come from angles, we have same shapes. But now because the numbers that represent those shapes are equal, we have same size, right? Same shape, same size is congruency. Okay, so angle 6 is congruent to angle 4. The definition of congruency. Okay, and look what we've proven. We proved that angle 6 was congruent to angle 4, which is what we were set out to do, right? But ultimately, what kind of angles were 6 and 4? Alternate interior, right? So we start off with two lines that were parallel, and we've now proven that alternate interior angles are congruent from that. Okay? And that's the idea about proof. We now have a logical reason why we can do that. Okay? And that's the same idea, guys. Earlier when going back to the apple, I took this angle here, and we kind of slid it up and put it there, right? Okay? But I could have, looked at these two being kind of supplementary, and then looked at these two being supplementary. Okay, if these two add to 180, these two add to 180, then these two have to be the same, right? And that's the argument that we just made mathematically. But in the fact, okay, we had several proofs that we've done. We did the vertical angle theorem. Let's abbreviate it. Vertical angle theorem. We did the congruent supplement theorem. Okay? And basically both of these were saying, okay, if you know we got vertical angles, you're starting off with two angles that are vertical, show that they're congruent. So the goal was to show a congruency of angles. The same thing happened in congruent supplement theorem. That if you start off with two angles that are congruent, two angles that are supplementary to the same angle, then they're congruent to one another. So you set off trying to prove another set of angles congruent. Here in this proof, we're trying to set off of the task of proving two angles congruent, right? So all three of these theorems, that one, and that one, give you some starting facts, and your goal then is to show angles congruent. In every single one of them, you get these two steps. You get that blue step 2 and the red step 3. And then after that follows step 4, step 5, and step 6. And it gets you to your conclusion. Does that make sense? So, the next time, I'm not saying it's going to work every single time, but the next time that you start off with some facts and you're given, and your goal is to prove two angles congruent, this is probably an approach to try. Does that make sense? We've seen it work 3-4 times already. It's probably going to work more. All right? And that's the idea that in working with these proofs, guys, you don't want to look at every single proof that we do as some new situation. We want to look at it as, okay, I've been here before. Similar situation before. How did I go through it then? And how can that help me to go through this current situation? All right? And that's just life in general. Every single time that you encounter something, okay? Trey comes to class tomorrow. I know instantly, because I've experienced it before, I'm going to take my water bottle, fill it up, be back later. Right? Every day. So I know how to address that because I've seen it before. Okay? And I just basically don't care. Does that make sense to everybody? All right. We're going to stop there. Obviously, time's almost out anyway. Pick this up tomorrow, finish it up tomorrow, talk about the other theorem. I opened up an assignment 3-2, but it's not due tomorrow. It's just open if you want to mess around with it, do some of them. It will not be due tomorrow. 2-6 is still open.